Hello, I am Tanmay Thakur. I am presenting my progress report presentation on my research topic for the 5 CS 530 class on the topic Investigate Anti-Random Testing when the internal nodes have anti-random values. The actual work on this research topic can be found in the paper submitted with this presentation. So here is the basic outline for the research project. The paper will include a brief abstract of my finding, the modifications and the previous work on anti-random testing and the results. The introduction will explain the motivation and my work towards the anti-random testing and my analysis of various previous proposed methods. It includes a review of the previous anti-random testing methods, the analysis of the result obtained for various examples studied using anti-random testing, self-testing of a sample bubble sort example which I have developed the algorithm and by using the checkpoint encoding and the test set compaction using the Hamming distance and the Cartesian distance, I have developed a test set vector compaction. So I have to verify it the code coverage using the ARTG tool which have been provided by Professor Malaya. Study of adaptive anti-random testing by combining it with CG constraint, analysis of example program using fast anti-random testing and comparing its computation requirement and basically its applicability for large anti-random testing programs, analysis of automatic efficient test generation technique for anti-random test set compaction using uh, using sample examples, understanding the rationale of using test coverage as a measure of fault detection effectiveness and to evaluate its reason using various papers. So finally, the results of studying various papers, various examples, testing various examples with anti-random testing methodology, and a conclusion for anti-random testing effectively. So till date, about more than 60% of my work is completed, which includes study and analysis of the anti-random testing methodology, extensive review of the test coverage results obtained using anti-random testing with checkpoint encoding, has mentioned in the paper, which includes the string matrix comparison, the triangle and the find algorithms, a review of about 9 papers for comparison of the results obtained from the anti-random testing, checkpoint encoding and test set compaction for my sample bubble sort program, study of the ARTG tool which I mentioned provided by Professor Malaya for test set coverage evaluation of the bubble sort example, comparative study of adaptive testing using CG constraint uh, proposed in various papers, comparison of the F measures using CG constraint variations, also which are proposed in various papers. Further, understanding the work done by automatic efficient test generation for test set compaction and efficiency, a comprehensive study of benefits with fast anti-random testing generation for reduction in computation required and its applicability of for long sequence input vectors, and its significance can be also studied with the help of sample examples. Development of rationale for uses of test coverage has a test detectability measure for reading several articles. Study of using coverage information to guide the test set generation has proposed in some papers. Future plan work includes testing of various sample examples for the coverage with anti-random testing methodology and understanding the use of the ARTG tool for the test set compaction and coverage information, and conclusively an attempt will be made to compare all adaptive anti-random methods proposed in various papers and design an algorithm which could reduce the computation requirement for the input space test generation. I hope that my article will be useful in the anti-random testing domain. Thank you.